slide shows where patients are actually getting any information related to clinical trials. And also, the preferred source of clinical trials from the perspective of patients. There's a big gap between those two. In other words, if you look at here, the green bar is when they are representing the preferred source from the perspective of patients. In other words, clinical trial participants, potential clinical trial patients are wanting to get the information of any clinical trial in which they can participate from their caring physicians, right? But actually, the way that they get this kind of information is from some other sources like TV promotionals and pharma country websites, even friends. So there's a big gap. Basically, this statistics shows the way that a clinical trial is currently being performed. In other words, busy physicians, they are lacking information as to where they can find the most appropriate clinical trials for their patients that might eventually benefit their patients. There's no information source. When there is information source here and there, but there's no sort of consultative approach that has been applied, helping physicians find easily and efficiently which kind of trials might be appropriate or eligible for my patients sitting in front of me right at this moment. There's no information source, and there's no way to find that efficiently. But you know what? If you look at the mindset of the patients, if he or she can find a piece of information about any clinical trials that they might be eligible for, and then they are willing to bring that information to their physicians, and that will lead them to, one way or another, being able to participate in those clinical trials eventually. So there is a gap, but this tells something that we need to think about. In other words, if there is a way or system, if you will, that connects both physicians and patients in a way that they can find the information of a clinical trials efficiently and practically, and it will be likely that those patients will be having a more chance to get into the clinical trial, right? The second thing is it has something to do with the complicated nature of modern clinical trials. In the previous session, we discussed that kind of aspect a little bit. Well, this is how a subject or patient is enrolled into a specific clinical trial. Well, eligibility assessment has to come upfront. In other words, we have to, as a physician, as a clinical trialist, I have to look for each subject's medical record very, very meticulously from A to Z, and then I try to match that with the specific eligibility criteria stipulated in the specific clinical trial protocol. Well, it sounds much easier than done. What do I mean by that? You know what? I have to go manually, one by one. And I have to eyeball. In other words, in the next slide, I'll show how complicated the current modern clinical trial protocols are. But let me just say that if you have 50 eligibility criteria items, then you have to go one by one. The information source is not collected. It's not been there in a way that I can go simply one side and just pull up and then find information. Bingo. No, it's not like that. I have to go this place and that place, another place, even in the EMR. And also I have to go on the paper and also other information sources such that I can find eventually at the last minute of the day, okay, I find one patient. It's very manual. So it's labor intensive and it's It's done manually, so it's prone to human errors. See, it's just, I do not know why this kind of practice has been doing forever and ever and ever. We live in the 21st century. We live in the era of all kinds of different information and communication technologies having prevailing, but still, the way that we are performing, particularly in the area of patient enrollment, eligibility assessment, is we live in a prehistory age. I don't know why, but that's the way it is. So, as you can see on the slide, if you look at the number of eligibility criteria items, well, 10 years ago it was approximately 30, but now it is 50. I read it personally, clinical trials where the number of eligibility criteria items were almost 100, particularly in the areas of late-phase clinical trials of patients with chronic diseases such as cancer, dementia, those kind of things. So you have to go one item by item. It's very laborious, error-prone, inefficient. So that's why I pay my clinical research coordinators for that kind of work. So you ask me why we have to pay even though we're not enrolling any single patient, because I have to hire a clinical research coordinator who is willing to going into this kind of laborious work process.
I have another expert question. Does an endpoint mean a patient, the subject of the trial, or what does endpoint mean? The number of endpoints.
Oh, this means, okay, so if you test for example, if you study a drug that treats a certain type of cancer, you can think of many different endpoints. Of course, the most important endpoint, clinical endpoint, is overall survival, or OS. But there are other types of endpoints that you might want to look at. For example, time to progression, time to tumor response, also some kind of biomarkers, whole lot different kind of endpoints. Well, in the past, there were only 2 or 3 endpoints. I mean, 10 years ago, 20 years ago. But now we have one primary single clinical endpoint along with 20 different endpoints we have to collect. But that does not necessarily mean that we analyze all the endpoints at the minute of the day. So we're simply collecting, but we don't look at those. So that's why it has been so unsuccessful in enrolling patients into clinical trials. And the clinical trial, at this point, I mean, the modern clinical trial, as of today, is too much complicated. So we came up with this idea. Well, actually, this is not something that we have accomplished, but this is something that we will accomplish based on the technology of artificial intelligence, particularly in deep learning and machine learning. So our idea is primarily based on why don't we use electronic medical record, but not in a way that logical kind of thing, but instead of us doing that kind of thing, why don't we ask machines do that kind of thing based on a whole lot of different kinds of algorithms, such as natural language processing, term expansion, whatever. I mean, I'm not an expert in machine learning, so I'm kind of mumbling here and there. But anyway, our idea is primarily why don't we use AI or machine learning or deep learning technologies in such that we train our machines to find eligible subjects automatically using electronic medical record. And that, well, that's the first step, and then we want to expand that kind of technology to cover other information such as public personal health records, such as rank load data and other genomic data, such that we enrich our trials in a way that eventually those patients who are going to be enrolled into the trial will be most likely to be responding to the treatment interest. And we then can provide that kind of service as a whole to the patient community, either through some kind of social network service or chatbot or whatever technology that you will. So we named this kind of concept PMATCH, which is the abbreviation or acronym, if you will, of the Precision Machine Learning Assisted Clinical Trial Disability Assessment using hospital records. Sounds sexy, right? Well, it took us a lot of time to come up with this kind of idea. Anyway, there are a couple of papers that have shown that this kind of approach can be implemented and will yield some kind of beneficial results, not only for physicians, but clinical research, faculty, staff members, and workforce, whatever. If you look at this slide, for example, the magnitude of workload for clinical research professionals having drastically reduced by applying this kind of technology from almost 1 to 8, which is 1/10. At the same time, the accuracy or performance, if you will, has increased also drastically by applying one by one this kind of machine learning or deep learning technology. So it is a proven concept, but there are a couple of issues that have not been resolved yet. One of which is, well, basically we have to deal with single-site electronic medical record system. But if we really want to make this kind of system work efficiently and beautifully as we intended, it has to be expanded to other hospitals and other sites. In other words, we have to deal with not a single electronic medical record system. Instead, we have to go beyond more than one EMR. Or if you may, or you may want to say that it can be an EHL, in other words, electronic health record, whatever the name is. So I came into this concept, the EHL for CR. It was basically, I have known the existence of this product for many years, but actually it was this time that I looked into this more carefully. So I just wanted to look if there is any possibility that this project can guide us to get to the next point. In other words, not only dealing with one EMR system, but also dealing with other EMR systems as well, using this approach. Okay? Well, since not all of you are experienced in this field, why don't I just give you some background of the terminology. For example, EMR stands for electronic medical record. And basically, any physician or any hospital can collect patient data and put them into an EMR system. Okay? So, while this doctor collects this pregnant woman, looks like a pregnant woman, but then he then puts her information into one EMR. Another patient here, this doctor puts her information. Sorry, I think it was made by Japanese people, so it's like a kind of sexist orientation. I'm sorry, but it wasn't intentional. In other words, I don't know why all those doctors are males and all patients are females, but anyway, I digress. He then can put her information into the EMR. So each EMR stands alone. They are not talking to each other. Okay? But if you have some way that connects to all those EMRs, then you then come up with electronic health record, or EHL, the last minute of the day. And if you add some personalized information, such as your heart rate, your emotion, your behavior, your whatever lifestyle or lifelog data, if you will, then we then come up with, we then are able to construct a PHL or personal health record. Okay. So this shows the current status EMR implication or implementation in Korea. As you can see, I'm sorry, some parts of this slide were written in Korean, but just bear with me, I'll explain. Okay, if you look at pretty much secondary and tertiary care hospitals in Korea, they haven't been able to implement any type of EMR. So almost 90% of those hospitals have implemented an EMR system into the site, followed by 80% and 60% in general hospital and also clinic. So pretty much approximately 70% of the hospitals in Korea, they have been able to implement any type of EMR one way or another. Okay? But if you look at the capability of those EMRs, particularly in terms of connecting, the interoperability, and the one thing, the first thing that you have to accomplish before you allow them to speak each other, is that it has to be put on some kind of a space. Typically, that's a web space. So we then call it web-based EHL. But if you look at the second part, you can see only secondary and tertiary care university hospital, and 30% of them haven't been able to put their EMRs into the space, typically a web. Okay, so what are the issues of EMR in Korea? Number one, almost 90.9% of them are homegrown. What do I mean by that? They just developed a new EMR system from scratch. In other words, they are inventing new well every time. In other words, in contrast with the situations in the United States, for example, where technically there are several EMR vendors, so each hospital simply selects one vendor or to another. But in Korea, each hospital has its homegrown EMR system. Very messy, very complicated. And also, the EMR system in Korea was primarily motivated by electronizing the way that each hospital sends the information to the government agency, which controls the reimbursement of all kind of medical things. So it was primarily financial, in other words, reimbursement purpose. So the quality of data in the EMR cannot be guaranteed. Maybe there are some overdiagnosis and there are some inaccuracies, but we do not know. It's just there. So it was not designed for research. So, only less than 10% of the information that you can find in the EMR can be used for any type of research. But actually, a whole lot of different kinds of information. For example, nurse records. It contains a lot of useful information, but they are not constructed. They are not entered into the system such that it can be easily converted into something that we can use for enhancing our research activities. No, we're not there yet. Lack of standardization. They don't speak to each other. Okay, data interoperability in Korea. Every single hospital has its own EMR system, and they are very silo-minded. So they don't like their EMR systems get exposed to elsewhere, and they don't like to share their data. And also data ownership. Each physician says, okay, this is my data because this is my patient's. But it's not like that. And also, the legal system in Korea as of today is too much strict. So if you de-identify any EMR system, no clinical research is going to be possible. But the current legal system has mandates that you have to identify any data if you want to use those. It's too strict, too impractical. Okay, so my question again. Then, can EHL foresee be an alternative platform to solve this kind of issue? And this is my last slide. I think, I don't know, the jury is still out. I do not know how many of you understand this English expression, but that simply means that we do not know yet. Well, I think that can be an option that we have to look for, but frankly speaking, at this point, I don't think I have an answer to that. So with that, I want to conclude my presentation. Thank you.
Time is quite over, so please, short question and short comments. We still have a question later, please. Okay.
So, I'm always very pleased if I can actually help. And so, this can both be a question and a comment. As you can guess, exactly these same issues are front and center in the U.S. And as you can guess from something that's about entrepreneurship, there are at least a dozen people who are already selling solutions to meet your needs. So, I'll give you 3 examples that you can look up. One of them is something called I2B2, which is a deep data analytics program that goes in, takes all your criteria, looks for features in the EMR. It's EMR agnostic, and so it looks for features in the EMR that allow you to rule in or rule out those criteria, and pulls up, here's your number of patients that meet or don't meet those criteria. That one is available worldwide. It's free, but I say that in quotes, because it's free only if your time is worth nothing, because you have to still adapt it to each specific thing. One that's not free, but is truly EMR independent, and is the only one I've ever seen that can deal with the dreaded comment field, because a lot of the information in electronic medical records is essentially hidden in PDFs. It's not in the particular place where you can search, and so you have to have a machine learning system that can read to find all that stuff. So there's something called datazoek. It's a Dutch word that means search, and so it's data Z-O-E-K. And it can actually do that, but I don't know whether it can read Korean. Don't know. And the third one, again, I don't know whether it can read Korean or not. It's free, but it's free because they take your data and sell it to third parties. Is something called Trinetics. And it's probably the biggest. It's used by at least 40% of US health systems. It's really good. Everything you're talking about, it can do. It's EMR agnostic, and it may or may not run into regulatory issues in Korea about the sanctity of patient data, even if it's de-identified going to a third party. So those are things that you could at least compare with as you're trying to develop your own solution. And so I guess what I would ask is, how much have you looked at? It's a very rapidly evolving field. Everything I told you would not have been true 2 years ago. And so how are you, my question is, how are you comparing what you want to do with what's already out in the wild, in the world, so that you don't have to reinvent all this stuff for Korea?
Well, thank you for your comment and information. Well, I think I felt like I should have made it much clearer when I presented, because we are not intending to develop, reinvent the wheel. In other words, we are not trying to redevelop the logics and the algorithms or whatever in the system. What we really want to try instead is to put everything together and create a system that connects all those already developed ideas, algorithms, and systems, whatever. So, but we'll definitely look at those systems to see if there's any kind of practical way that we can use that to facilitate this kind of thing further. The biggest, I think the most, one of the most difficult things that we have to try to solve is we have to deal with the mixed language of both English and Korean, particularly in the prior note written by physicians. I do not know how much you're familiar with, but I think you are. I mean, as a physician, I do my charting. I mean, I write my prior notes in both English and Korean, but there is no rule. It's haphazardly combined, and sometimes I do just use keywords in English and then some kind of supporting words in Korean, or the other way around. Sometimes I use verbs. I write verbs in English and the other way around. So many kind of complicated things. So maybe one of the unique or novel things that we will be trying to implement into the system is to deal with that kind of weirdness situation where two languages, or sometimes more than two, are connected.
That's why you need AIs. AIs are smarter than humans.
Well, yeah, you're right, but we'll look at it. Because
I'd be happy to give you the names offline.
Yeah.
Because the thing that you just outlined is a really fascinating problem for a computer scientist. They love those kind of things.
Yeah.
Right? Where you have to be able to recognize and parse meanings from disconnected meanings. So I know one NASA engineer that works on this who would just love that.
Yeah.
Because it's not only true in Korea, it's also true in Mexico, for example, where people speak Spanish. And so half of it will be in Spanish and half of it will be in English, and they got to figure that out.
Yeah, we're more than happy to have that kind of information from you. And actually, we have to start working out on this idea several months ago. So we're still looking for some ways to improve this kind of concept, while we're looking for those people who have technologies which will allow us to implement this kind of concept into practice. So I'll definitely talk to you.
Okay, you have a last question at this point.
Actually, first of all, you made an excellent presentation from the view of a clinical researcher. You outlined extremely well the challenges and the best practice you are doing. My comment here is, as George made the comment on looking at available providers. I think we have to deal with two levels. One level is, and this is when you come to individual providers, what can one person, one institution allow? And there's a lot out there. And I realize that especially in the IT area, people are working exactly like this. They provide individual solutions for one individual problem. But here, I think we have to step up to the very next level. What are the challenges not one single institution can do alone? And this is the EHR4CR approach. And so on that level, you need all the individual, I think, providers to be part of this. But you never get there to your objective if you just do it with individual providers. And I would just change the slide and would say, not the jury is still out, I would say the money is not yet there. Because this could be a plea to Korean government and institutions to fund really such an endeavor, and you could link it automatically to a European initiative. And this would pay off, I'm absolutely sure.
Thank you for your encouraging comment. Thank you.
Okay, thank you very much, Professor Howard. We welcome the speaker, Dr. Hyun-Jin